Alright, so going over this review for chapter 8, starting off with proportions, which most of this chapter is all about proportions. So to solve a proportion, we start by cross multiplying. So 7 times 6 is going to give us 42. I'm going to set that equal to 4 times n. Divide both sides by the 4. And we're going to end up with n equals 10.5. Next one, another proportion, just a little more complicated version. So we're still going to cross multiply. So we're going to have 8 times x plus 6. It's going to equal 3 times 10. So distribute the 8. 8x plus 48 is going to equal 30. Subtract the 48 from both sides, because 8x equals negative 18, and divide by the 8. And our x is going to equal negative 2.25. And number 3, another proportion. Cross multiply, so we get 3 times n. It's going to equal 7 times n plus 8. Distribute that 7. 3n equals 7n plus 56. Subtract 7n from both sides. That's going to give us negative 4n equals 56. Divide by the negative 4. And our n is going to equal negative 14. Alright, so next one, 4 and 5, determine if the polygons are similar. First thing we want to check for is to make sure that the corresponding angles are congruent. So this angle is congruent with that one, this one's congruent with that one, this one and that one are congruent, and this one and that one are congruent. So all the angles are good. So then we want to check to see that the sides are proportional. So we're going with the top numbers. 8 would go with 4. 9.2 would match up with 4.6. And 14 would go with 7. We've got another 9.2 and 4.6, but since we've got those same numbers in there already, we don't have to do that twice. And simplify or reduce the fractions. 8 over 4, they both divide by 4, or 8 divides evenly by 4 to give us 2 over 1. 9.2 over 4.6 actually divides out to be 2 over 1. And 14 over 7, 7 goes into 14 twice, 2 over 1. So all three of those do equal each other. So those two polygons are similar. Alright, then the next one, all 4 angles in both of them are right angles, so all the angles are good. So then we start checking proportionality of the sides, and these are not oriented the same because we see that the short side here is 16, the short side on this one's 25, so those go together, and the 20 and the 30 go together, which the other 2 sides are just copies of those 2, so we just have to check 2 sides. So 16 over 25 has to equal 20 over 30. And 16 and 25 have no common factors, so that just stays 16 over 25. 20 over 30, those both have a factor of 10. Take those to 2/3. So 16 over 25 is not equal to 2/3. So those are going to be not similar. Alright, number 6, polygons in each pair are similar. Find the scale factor for the smaller figure to the larger figure. So, since they're already telling us that they are similar, we only have to check one set of corresponding sides. So we can go with the bottom sides, 3 and 9. 3 over 9. Reduce the fraction if you can, which both of those divide by 3, which would give us 1 over 3. Or write it as a ratio with the colon as 1 to 3. And it's small to large, so you want the smaller number first. So 1 to 3 be our ratio. Right, polygons in each pair are similar. Find the missing side length. Right, so for number 7, create a proportion with our corresponding sides. So 16 and 24 are going to go together, make one fraction or one ratio. That's going to equal the 6 over the missing item. We're going to call that x. So we can cross multiply. It's going to give us 16x. It's going to equal, and 24 times 6, which is 144. Divide both sides by 16. And we're going to get the x equals 9. Alright, so solve for x. The polygons in each pair are similar. So same idea as the last one basically. We know they're similar, so we can set up a proportion. We can go 6 over 12. It's going to equal 4 over x plus 1. Cross multiply. And have 6 times x plus 1 equals 48. 4 times 4. Distribute the 6. 6x plus 6 equals 48. Subtract 6 from both sides. The 6x equals 42. And divide by the 6. We get x equals 7. And the next one, we're going to use our scale factor, 1 to 3, to create a fraction, 1 over 3. And this is a over b. So our a term that they gave us is 3 over the b term they gave us, which is x. So cross multiply, and we're going to get x equals 9. Right. 10 and 11, stating if the triangles in each pair are similar. If so, state how you know they're similar and complete the similarity statement. So with triangles, we have 3 possibilities for similarity. Angle, angle, side, angle, side, or side, side, side. So angle, angle, you're looking for 2 angles that are congruent. Side, angle, side, you're looking for one set of angles that are congruent, and then the 2 sides that make each one of those angles being proportional. And then side, 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 you're just looking for all 3 sides being proportional. And you usually tell what you're trying to solve for based on what they give you. Which if we look at 10, we have no angles given to us, but we have 3 side measures. So we're going to check it for side, side, side. So checking to see if all 3 sides are proportional. So I can get 6 over 12. And then that will match up with 9 over 18. And then that will go with 12 and 24. Right, 6 over 12. 6 is half of 12, so that's 1/2. 9 over 18. That will reduce to 1/2. over 24 reduces to 1/2. So all three of those are equal. So these are similar. And it's because all three sides are proportional. So it's side, side, side. And the similarity statement, triangle WVU, is going to be similar to triangle FGH, putting the corresponding parts in order. Alright, so then number 11, if we look, we got an angle given here, an angle given here. Those happen to be the same angles, so we know that those are congruent. And then we have no side lengths given to us. So the only possibility here is going to be angle, angle, because we don't have any sides to make side, angle, side, or side, side, side. So the other thing we can recognize is that there's an intersection here in the middle at point S, which means that on each side of that intersection we have a set of vertical angles, and the vertical angles should be congruent. And so that gives us two angles that are congruent. So these triangles are similar by angle, angle, and triangle STU is similar to triangle SBC. Alright, 12 through 14, we're finding the missing length indicated. And number 12, we've got an angle bisector, because these two angles are the same. When we have an angle bisector, the two parts that it splits the opposite side into are proportional with the two sides of the triangle. So, since the whole thing is 13, and that part is 4, then 13 minus 4 is going to give us 9 for that section. That question mark will be our x that we're solving for. So 4 over 9 is going to equal 8 over x. And just make sure when you set these up, we use the 4, which is on the left side of this dividing line, as the top, and for this ratio, and the 8 that is on this side of the dividing line needs to go on top over the x, which is on the right side of that line. So now cross multiply, that gives us 4x equals 72, and divide by the 4, and our x is going to equal 18. Number 13, we have a triangle with a line dividing into the triangle that is parallel with one of the sides, intersecting the other two sides. So the two parts on this side of the triangle are proportional with the two parts on this side. So if I do 2 over 3, then that would put 4 over x, or question mark our x. Cross multiply, that's going to give us 2x equals 12, divide by 2, and our x equals 6. 14, we have 3 parallel lines. All of them have the same arrowhead mark showing that they're parallel, intersecting 2 transversals. So in this case, the parallel lines divide these transversals into proportional parts. So this whole distance here is 16, this part's 10, so that means that that part there has to be 6. And so if I do 9 over x, or a question mark, that's going to equal 6 over 10. So we did this part down here as the top, so we need this part in this section on the top on the other one. Cross multiply, that's going to give us 90 equals 6x divided by 6, and 90 divided by 6 is going to be 15 for our x value. So 15, write a rule to describe each transformation. So The original triangle is the black triangle there. The blue triangle, D prime, E prime, F prime is our dilation. And so if we want the rule, we need to know what the scale factor is. And so remember that the scale factor can be the distance from the center, which the center is our origin here. Distance from our center to the prime point over the distance of the center to the original point. And so the best thing to look for is 2 points that are perfectly on intersections, which neither one of these, or this one is not perfectly on intersection and this one is not. If I look at D and D prime, they're both sitting on the x-axis. D is at 2 or -2 and D prime is at -3. So the distance is 1, 2 to D and 1, 2, 3 to D prime. So the distance to D prime goes on top, which is 3. Distance to D goes on bottom, which is 2. So our scale factor is 3/2. So our rule is that this is a dilation of 3/2 about the origin. And it doesn't ask it here, but since our scale factor is larger than 1, or we can also see clearly that the black triangle is smaller than the blue triangle, then we could also label this as an enlargement. Once again, it didn't ask for that, but we can put it there. Alright, so then find the coordinates of the vertices of each figure after the given transformation. So our transformation is a dilation of 1.5 about the origin. So to get the transformed vertices for all the prime values, we need to multiply each of these original coordinates by the scale factor, 1.5. So for L prime, it's 1.5 times -1 for the x, and 1.5 times -2 for the y. So L prime is going to be -1.5 and -3. There's the L prime value. K prime is going to be 1.5 times 1 for the x, 1.5 times 3 for the y. So K prime is going to be 1.5, 4.5. And then for J prime, it's going to be 1.5 times 2 for the x and 1.5 times 2 for the y, giving us a J prime of 3, 3. So there are our new coordinates for the vertices of the transformation, L prime, K prime, J prime. And that concludes the review.